So for this problem we need the frequency minimum. So we have the frequency is equal to this frequency they gave us, that is equal to 440 multiplied by the velocity of the sound divided by the velocity of the sound, and because it is going away is plus the velocity, but we don't know the velocity, so we can know it by this equation of kinetic energy. And if we solve for the velocity, we know that that velocity is equal to 1 meter per second. So when we know this, we can know this. So we put 1, and this is equal to 439 hertz. This is a minimum frequency, and the maximum frequency is equal to the velocity of the sound, and because this is approaching the observer is minus 1, and this is equal to 441.3 hertz. They ask us for the decibels minimum, so we know that this is the equation for the decibels. So we have the maximum that is equal to this equation, and for the minimum decibels we don't know the minimum, so we put like a letter. But we don't know the intensity of the sound, but we know that the intensity is equal to this, but we don't know the power. But if we use the property of the logarithms, that is this. If we divide it, we can eliminate the power and know the decibels. So we have the 60 minus this is divided by the power and the error, and the power divided by, and we eliminate this power and this power, this constant, and this is equal to 60 minus the minimum decibels equal to 10 logarithm of R2 radio 2 squared divided by radio 1 squared. So if we solve for this, we know that this is equal to 58.98 decibels, and these are the minimum decibels this man can hear. So for this equation we know that this is K and this is omega. So they ask for the loops, and we know that K is equal to this, is equal to pi. So we have 2 pi divided by pi. We can eliminate, and this is equal to 2 meters. And they tell us that the length of the string is equal to 3. And we know that the length of the now we know the size of the length. So if the white plate tells us that are 3 meters and the length are 2 meters, we know that it will be like this, but we are missing 1 meter, so we complete it like this. And they ask for the number of loops, and we can know like here are 1, 2, and 3. There are three loops in this word. So for the frequency, we know the W omega is equal to 100 pi. So we just substitute and know that the frequency is 50. For the letter C, they told us that the frequency will be constant. And the tension will be increased by 9. Will be 9 times. So they ask for the loops. If we add tension to the wire, so we know that the formula of the velocity is equal to this. So, and the velocity will be square root 9 times the force, because the tension is augmented, divided by mu. So we will have this then we know that we have 3 times this. Therefore, we will have that this one was 2 meters. There A. So we will have that, and the frequency is constant, so we can eliminate it. So we will have the 6 times with the length number 2. And to know the number of loops, we can draw it again. And because this is 6 meters, we will have this and this, but we don't have this length of wire, so we will have just 1 loop in this side of the wire. So the number of loops will be 1.